we're going to be digging deep here into your understanding of straight line graphs, making sure you definitely understand what each of these things mean and how they all connect together, most importantly. An example first. I've given you the equation of a straight line here. Can you fill in all of these things about the straight line? Pause the video first and have a go yourself before I talk through it. Okay, the first thing that I definitely want to do is just a very quick sketch of the graph. Now you can see how rough this sketch is going to be. A sketch is just an impression of the key things that are going on. Okay, so I know that in an equation of a graph, this number here is the y-axis intercept. So the intercept is 0 along and 2 up. And I know that this number here that's timesing the x is the gradient. The gradient being how far up it goes for every 1 across. I could draw that on, I guess. 1 across and 5 up. The gradient is 5. Just having this sketch here makes it a bit clearer in my own head. It's going uphill and it crosses here. Okay, when x equals 0, y equals... That's basically the same question as that. When x equals 0, y is 2. The next, when x equals 1, well, let's plug 1 in here. 5 times 1 is 5, and 2 is 7. When x is 10, same thing. We've got 50 and 2. 52. The equation of a parallel line. Any parallel line. Well, a parallel line just means that it has to have the same gradient. So y equals 5x and then a random number here. Let's write minus 100. There we go. That's all the way down there. Specifically, parallel line which goes through 0, 7. Well, 0, 7 is here. That just means it's got this, oh, there, it looks like. That just means it's got the same gradient and a y-axis intercept of 7 instead. Y equals 5x and 7. The value of x when y equals 0. So y equals 0 means we haven't left the ground. Y equals 0 is here and we want the x value. How are we going to find that? We need to do a little equation, I think. We need to solve where the equation equals 0, where y equals 0. Well, that gives us, if we take away this 2 from both sides, we get 5x needs to be negative 2, and then divide both sides by 5. X equals minus 2/5. You could write that as minus 0.4, but minus 2/5 as a fraction is fine. Great. All of those bits of information have just come from this little equation here. I think that's pretty impressive. Now that, if you understand all those terms, shouldn't have been too hard. I'm going to give you a second thing here. Here we go, and you can see how this is different. I'm not going to give you the equation this time, but I've given you these two bits of information. Again, before I go through this example, try to do it yourself first. The best way to get better at maths is to do it yourself. So try it yourself, pause the video, and then I'll go through it. Okay, as before, the very first thing that I want to do is draw a sketch, because that's going to make it so much clearer in my head. Oh, that's a bit neater than last time, isn't it? When x is 1, y is 5. Again, it's just a sketch. So as long as it's roughly in the right place, it's fine. When x is 10, y is 32. How are we going to get all the necessary... Ah, that was nowhere near. 1, 5 is now there. How are we going to get all of the necessary bits of information from these 2 points? The first thing that I want to figure out is the gradient. I know that the gradient is how far up it goes for every 1 along. So let's try and figure this out. Now, if I draw this here, I can see to get from 1 to 10, that's 9 across. And from 5 to 32, that's 27 up. So for 9 across, that's 27 up. So for every 1 across, I reckon that must be 3 up. A different way to calculate the gradient, a better way really to calculate the gradient, is to think the difference in y divided by the difference in x. That will give us exactly how far up it goes for every 1 if we divide that 27 by 9. 27 by 9 is 3. The gradient is 3. We're stuck in now. Fantastic. Okay. Now there are a couple of ways of finding this y-intercept here. We could do a bit of algebra and say, well, if y equals 3x plus something, that looks like the equation, and then I could put this coordinate in and say, well, 5 needs to be 3 times 1, add that something, 5 equals 3 add 2. So the intercept is 2. That c must be 2. See, I did that there. I used the gradient and a coordinate that it passes through in order to figure out what this added thing needs to be. A quicker way of doing that would be to think of this sketch again. The sketch is really useful because for every 1 across, it goes 3 up. So to get back to here, 5 take away 3 is 2. 2 different ways of finding it there. Y-intercept is 2, and I'll tell you what, let's write that as 0, 2, and this is just 2. All right, I think it's going to be easy from here. Parallel line, well, that just needs to be the same gradient. Let's leave it like that, plus nothing. Parallel line which goes through there. 3x adds 7. And then the value of x when y equals 0, we're going to solve that little equation again. We've got 3x add 2. Remember, it's this one, 3x add 2 equals 0. So 3x needs to be minus 2. So x is negative 2/3. That makes sense that it's negatives because it's over here, negative 2/3. Fantastic. And we found all the bits of information again. This is really testing how all of these bits of understanding link together, and it's all about this one graph. The way I could test that, the way I could check my answers easily, because at the moment all this could be complete rubbish. The way I'm gonna check it is by going on to my good friend desmos.com, because now I can plot the graph that we had, y equals 3x plus 2, and just check that it goes through those coordinates that we needed it to go through. We were given that x is 1, y equals 5, and this coordinate here, I need to check that it definitely goes through those coordinates. Let's check. Here we go. So 1, 5, it definitely goes through 1, 5. And 1032, crossing my fingers, yes, 1032. That's such an easy way of checking, just plugging it into Desi and making sure that it works. You can do that yourself. Do that yourself for what, you might ask? Well, for all of these ones. This is some great practice here. I've given you different bits of information for each one. So this top line here, you can fill in all the information for this equation. This one here is a different one. This one here is a different one. So there's 1, 2, 3, 4, 5, 6, 7, 8 lines there. Have a go yourself. Try and do it all. Once you've done that one, lucky you, there are 8 more there. So there are 16 bits of practice for you there. Each one you can check on Desmos and get better and better and better and really improve your understanding. Good luck with it.